if you can write that name down. So we're doing resolving vectors now. There you go. Gao said she's going to watch this video later, so maybe we should leave a message for her. We should say something to see if she watches it, you know, like, I would like you to bring me a cappuccino for the next class. Now we'll see if Gao got that message and if she brings me a cappuccino. Alright, let's have a look. Okay, so resolving vectors now. Okay, do you know these words, horizontal and vertical?
Yeah.
What's horizontal?
Mm-hmm.
Which one is horizontal? This or this? Yes, and vertical is like this. Good. So horizontal and vertical vectors can be added together, just like any two. And this is common in mechanics. And so is the reverse. So that's taking a vector and writing it as the sum of a horizontal and vertical. So what I mean, just to be clear, if I want this plus this, that equals that, and this is the answer. Yeah? But what we really like is when we have this and we say it equals that plus that.
Oh.
You see, this way is easy. This is easy. You just put this here and there you go. But this one's a little bit harder. You have this vector and you want to write it as a horizontal and a vertical. Here, horizontal, vertical, resultant. But here you start with the resultant, you want horizontal and vertical. So, we call this process resolving. Whoops. Resolving. Yeah. You know, it's like, do you know this word solve in maths?
Yeah.
Find the answer.
Yeah.
So it's resolving.
Like
It's like
check.
Actually kind of like that, yeah. So we'll learn how to do this today, how to resolve. Yeah. Okay. This one here, this is just called adding, and this is called resolving. So adding is easy, right? This is easy to do.
Yeah. And then.
Okay.
Yeah.
Yep. Right. So to resolve, we'll need to use some maths. You know this is called Pythagoras. Pythagoras said a squared equals b squared plus c squared. What's his name in Chinese? It's something like go D or something, I don't know. Do you know his name?
Yeah.
You know this person, Pythagoras?
I don't know.
You don't know his name in Chinese?
Yeah.
He's maybe, I don't know, 3,000 whatever years ago.
Go.
Yeah. Do you know this? Is that his name? No.
English name. I don't know.
Like, what do you call this in Chinese? This here. What would you call that in Chinese?
Let me think. Maybe just go.
Okay. You know this is from basic school.
Yeah.
Very basic.
Yeah.
This squared plus equals this squared plus this squared.
Yeah.
So that's basic. Okay. So why do we need Pythagoras? Well, if you know how long this is and how long this is, you can know how long this is.
Yeah.
That's why it's useful. Okay. You know what? I think it would be good if you write his name down, his English name. You need to know this, his name.
Oh.
Pythagoras. Yeah. Pythagoras Theorem.
Zero.
Okie dokie, that's good. Okay. Now, let's continue. So, here's a very, very, very simple question. What is the magnitude of the resultant if you add 3 meters, 3 meters east and 4 meters? No, we know it's 5, because it's 3, 4, 5 triangle. Yeah, so we know this one. What's the other triangle? The other famous one? You have 3, 4, 5 and...
maybe 1, 1...
root 2. And what about 5, 12?
13.
Good. Okay, very good. Right. Now, here's some words that you probably don't know. So in this triangle, here's the angle. We call this side the opposite. Are these new words, or do you know them? You know this one, opposite.
Opposite.
Yeah, okay. Do you know this one, adjacent? No.
Yeah, I don't know.
Yeah. And this one is called hypotenuse.
Hypotenuse.
Yeah.
I know Chinese name.
Yeah, no, I'm sure you know it in Chinese for sure, yeah. Yeah, yeah. What's the name of this letter?
This letter?
Yeah, what's this called?
Oh.
Greek letter.
Oh, I forgot. C. Cycle.
No.
Beta.
Nope, not beta. Theta.
Theta.
Theta, yeah, theta.
Oh, I don't know.
You don't know this one, theta.
Theta.
Yeah. And actually, do you know what this part is called?
90 degrees.
Yeah, correct, 90 degrees. It has a name.
Corner.
Not bad, but not corner. We call this right angle.
Right angle.
Yeah, so this is called right angle, and this is called theta. Now, you were going to call this one here, you were going to say cycle. There is a Greek letter that's kind of like this called sigma. Were you thinking of this, sigma?
Sigma.
Yeah, sigma. Sigma, sorry, not sigma, sigma. This one is theta, and this one is sigma. You don't know this one? Okay. This one?
Alpha.
Yeah.
Beta.
Yeah.
I don't know.
Gamma.
Oh, gamma. Oh.
Yeah.
I don't know.
Delta.
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 I mean the
No, this is...
triangle is delta.
No, this is small, this is big. You know, like small a, big A. Small b, big B. Small c, big C. Small delta, big delta. There's 2. Yeah.
I can remember this.
Like, you know, do you know this one?
I forgot. Just
Or it's the same as this. Omega.
Omega.
Yeah, yeah. Anyways, don't worry, we'll cover all of these. So today, that's theta. Theta. Okay. So, do you know sine, cos, tan?
Yeah.
Okay. So which should we use, sine, cos, tan? Usually we use tan.
Oh.
Because we usually know this and this.
Yeah.
So we usually use tan to get theta. So we can say that tan inverse, opposite over adjacent, that gives us the direction, the theta. Tan inverse.
Oh, why why is
This?
yeah?
Yeah, just, let's see. So like, I could say, I know, tan 45 degrees equals 1.
Yeah.
Because you know the triangle here.
Yeah.
So we can say 45 degrees equals tan inverse 1. In other words, tan takes the side and gives me an angle. Sorry, apologies. You have an angle, you put it into tan, and you get a number.
Yeah.
Like here. But if you put the number into tan inverse on the calculator, it brings you back to the angle.
Oh.
So tan inverse the number gives you the angle.
So just tan.
So like, what's like, you know, tan 60 degrees, what's that now, let me think. There's 60, there's 1, there's 2, and there's root 3. So, root 3.
Oh, no.
Yeah, just root 3.
Root 3.
So if you type in tan inverse root 3, it should say 60 degrees.
Oh.
Yeah. So if you type in tan inverse opposite over adjacent, you get theta.
Can I just remember the cycle angle?
The cycle? What do you
You draw the cycle.
Oh, yeah. You mean like this?
Yeah.
Yeah, so actually let me make that a bit clearer for you. So you have angle, you put that into tan, and you get what's called a ratio. Yeah, that means like, you know, like something like 1 over root 2, like a fraction. Yeah. It means a number. And then you put that back into tan inverse, and you get back an angle. So, for example, yeah, let's take an example. If you have 60 degrees, and then you press tan, you'll get root 3 over 1. And then if you put that into your calculator, tan inverse, it'll take you back to 60. Okay. Yeah.
Okay.
Right, that's okay? Yep. Now let's see. So, use your calculator. Tell me the angle, the direction here. 3 meters east and 4 meters north. What's the angle? So you'll need to use your calculator.
Just try.
You can draw it, yeah?
East, up.
Yeah. And north, yeah. Yeah.
How to say the E?
Yeah, so if you want to draw it, look here. That's east.
40.
That's north.
Degree.
Is it 45? Because it's 3 and 4.
Oh.
Yeah.
Oh, it's 53.
I think so.
Oh, 3, 4. Oh, it's 13.7.
Why don't you check on the calculator?
Because I remember this.
It's an important one. Yeah. But check. What would you type in?
How to calculate?
Let me show you. So you need to press, look, here, Shift, tan.
Oh, shift.
Yeah.
And 5.
Mm-mm. Four,
Oh,
3.
3.
Yeah.
Oh.
What you get?
15.
53 point.
1, 3, 1. Oh, that's it.
Yeah, yeah. So your 36 was for this part.
Oh.
Yeah, yeah. Because
but it doesn't.
oh, it's important. Yeah, you did this one.
Oh.
That's the 36, I think.
Oh, yeah.
Yeah, yeah. Yeah, yeah, yeah. Now, yeah. I think you should write this down. You should write this down as an example.
Yeah.
Yeah? Okay. So, let's see.
And direction.
Mm-hmm. Oh, yeah, sorry. East 53.13 degrees north. Yeah. Yeah. Okay, let's continue. So, do you know this? Sine is opposite over hypotenuse.
Yeah.
Cos, yeah. Adjacent and tan. So you know these 3?
Yeah.
Okay, so.
Oh, the last one.
Tan. Yeah.
Opposite. Okay, I remember.
You remember? Now, look at this here. Suppose I give you this, and you know the magnitude. Let's say the magnitude is, well, I don't know, or. And let's say you also know the angle, the direction. We'll call it theta. I want to know what is this and what is this. Okay? So you could say sine cos theta equals x over or. So therefore, x equals or cos theta.
Yeah.
And you can say sine theta equals y over or. Yeah, so y equals or sine theta.
Yeah.
So this is a useful trick. If this is or and this is theta, then this side is or cos theta, and this side is or sine theta. Now, this is important. Remember, the side with the theta is the cos. So, for example, you know, if I draw something like this, and I ask you for this and this, well, what you can do is, because the theta touches this, we know that this one is the cos. This is the cos one and this is the sine. You know, or if I have something, you know, whatever, something funny, you know, I can say this is the cos and this is the sine. Or whatever. I'm just making up one, like our, you know, I don't know. So, you know, you get the idea.
I have some confused.
If this is theta,
yeah,
and I want this, and I want this,
yeah,
which is this cos or sine? This side. You see, this is cos.
Yeah.
But you don't need to think. Whichever side has the theta is the cos.
Okay.
Just remember that, yeah. So this side is the sine. Because it hasn't no theta.
Just R sine, R.
Yes, yeah.
Okay.
So here, where's my page gone?
Remember this very important.
Very useful.
Yeah, I always confuse the
Mix the two.
me.
Yeah, this is the useful.
Yeah.
I think that's enough. Yeah, you can just remember that. So let's have a look now. Okay, so now back to some definitions. So speed, we saw speed is distance over time.
Yeah.
Yeah, but there's another way to find speed. Speed is the magnitude of velocity.
Velocity.
Yeah, so look here. If he goes this way, this is 3 meters per second and this is 4 meters per second. We say his speed is 5 meters per second.
Yeah.
So the speed is the magnitude of the velocity. You know, it's this length. So it's square root 3 squared plus 4 squared. That's another way to find the speed.
In the velocity.
Mm-hmm.
Velocity means
With direction. So this is velocity because it's 3 east and 4 north. This is no direction. It's just a number. So it's just speed.
And where is that velocity?
What do you mean? Oh, which lesson is velocity? Yeah, this one, the vector triangle. Like question 2. A boat sails 4 kilometers west and then 4 kilometers south. That's like in 1 hour. So you see here what was the velocity and what is the speed. The difference is this one is only a number, but this one has a direction.
Oh, direction.
Yeah.
Means I know.
Now there's 2 ways to give a direction. You can give a direction like this. You can say, northeast.
Yeah.
Or you can give the direction like this. You can say 1 east and 1 north. See this? It's the same thing, It's the same thing. So,
but speed is different.
Yeah. Speed is like this length.
Yeah.
So speed is root 2 here. Yeah.
Speed is
root 2.
Oh.
If you go 1 meter,
Yeah.
1 meter in 1 second,
Yeah.
so you go like this, then that means you go root 2 in 1 second. Because, if I say this, I know he doesn't really go like this. He really goes like this.
Yeah.
Do you know that? I know it's a bit confusing.
I mean, speed's no direction.
Yeah.
So just
So what would you say?
just 2 per 1. Just speed is 2.
Yeah, speed is just this.
It's 2.
2? Not root 2?
But not so. Velocity is
Velocity. Oh, no, I got you. Sorry, yeah. Velocity is 1 meter per second east and 1 meter per second north. Or you could say it like this. root 2 meters per second northeast. So they're nearly, it's a little different,
Oh, but they have the same answer.
In this one, yeah. Now, it was different here because in this example, he moves like this.
Yeah.
Whereas in this example, he really did move east and then turned and moved north. So it's a little different.
So speed is the
hypotenuse. Yeah. You add them. Yeah. Well, not for this one. For this one. Yeah.
So if this one just 2 meter.
Yeah. This one here, the speed is 2 meters per second. If he goes here and then he goes here, and this is 1 meter and 1 meter.
But if velocity is just how to say
the square root?
Square.
Oh, the velocity here? Yeah, the velocity would be square root 2 meters per second northeast.
So
you know? Yeah. Okay, good.
So complex.
So, yes, it's quite complicated. Okay, can you write this down?
Okay.
Yeah. Okay? Yep. Right. Okay. Here's one for you to try. So consider this vector. 10 meters per second horizontally and 20 meters per second vertically. So let me draw that for you. 10 this way and 20 this way. I want to know the magnitude and I want to know the direction. So using your calculator, give me those two. So magnitude and direction. Now press SD. Yeah, so that's 22.4. 22.4 meters per second. Okay, now the direction.
The corner the
tan. Yeah.
Oh. Means 10. Sine 20.
0.4.
And
oh yeah, east 63.4 north.
Okay.
Yeah. Is it okay?
Yeah.
Not so bad? Okay, do you want to write this down? Example? Yep. Okay. Okay. Now, here we have to resolve. So we have a ship sailing 15 kilometers per hour at a bearing of 30. How fast is it traveling to the east and to the north? So what we have is here, this is 30, and this is 15 kilometers per hour. And I want to know how much east is that and how much north is that. So, which one is cos and which one is sine?
This side is cosine.
Which one, north or east?
North is cos.
Yeah, and what would this side equal? This one would be what?
15 cosine 30.
And this one?
15 sine 30.
Okay. So the answer is east. So, and then north. Okay, so tell me what these two answers are.
Okay, east is 7.5.
Yeah, I think so, isn't it? 7.5 kilometers per hour east and
12.99.
12.99? So 13?
Yeah.
Let's see, what did you get? 12.9, yeah, okay, so 13 really, isn't it? Yeah. 13 kilometers per hour north.
Yeah. Is that our example?
Huh?
Example?
That's all.
Okay.
Easy peasy, huh?
Yeah. Just very quick.
Yeah, no problem. Happy?
Yeah. Easy.
Okay. I think that's all. Yeah. So let's have a look at some book questions. How are we doing for time? Ah, good. Let's see. Resolving. Yeah, I think these are all okay. So, like for example, you see here in the first one, a ball is kicked so that it leaves the ground with a speed of 30. So someone kicks a ball and it leaves the ground at 30 meters per second, and at an angle of 30. With the help of a diagram, resolve this vector into a horizontal and a vertical. So this would be 30 cos 30, and this one here is 30 sine 30. So you can see the answer is 25.98, or really 26 horizontally and 15 vertically. So these are all, I think, pretty easy.
Yeah.
Gets a little bit more interesting here, but I don't think they're too bad. A pickup truck is towing a car. The truck is at an angle of 45 and the force is 2000. So again, what's the horizontal, what's the vertical? So maybe 5 minutes, you think, maybe it can be finished, and then we can go to the next lesson then. I'll close this